Alright, in this video I'm going to explain isotopic notation and how to find the number of subatomic particles in an atom. So let's start with isotopic notation. This right here, and I'll put a box around it, is just the generic way to do isotopic notation. And you can read the key up here that X is going to be the symbol of the element. You write the whole symbol. A represents the mass number, and Z is the atomic number. You're going to find both of these things off of the periodic table. Remember that the atomic number is always a whole number, and the mass number is usually a decimal. Mass is always larger, so you're going to have a larger number on top and a smaller number on the bottom. Okay, so here's an example of the isotopic symbol for fluorine. It has 19 as the mass number, 9 as the atomic number. Both of those came from the periodic table. So on the periodic table, again, you're going to have to round your mass number up. If I look at the periodic table in front of me, it says that fluorine's is 19.00. So that one's kind of easy. So let's look at another one. Let's look at chlorine. Chlorine on the periodic table, the one in front of me, has an atomic number above it of 17 and a mass number of 35.45. When I write that as an isotopic symbol, I'm going to put the 17 on the bottom, and the 35.45 is going to go up top, but I have to round it. I'm going to round it to the ones place. The 4 is going to make the 5 stay where it's at, so I'm going to write 35. 3517 Cl would be the isotopic notation for chlorine. Now, if you look at the rest of the information up here at the top, or if you're going by the notes that I've given you in class, how you find the parts of the atom are based off of the atomic number and the mass number. The atomic number is the easiest place to start. It tells you the number of protons. So I'm going to write this down here. I'm going to change it to the word atomic number, and then I'm going to change this so that it says mass number instead of Z and A. So when we look at a symbol like sodium on the periodic table, its name, we just copy off what the table says is sodium. Its atomic number is the whole number. It's the smaller of the two is 11, and its mass number on the table is 22.99. That would round up to 23. From there, we can figure out protons, electrons, and neutrons. I'm going to write the isotopic symbol of it first using these two numbers, that this is 23 and this is 11. My 3 kind of looks like a 3. I think I'm just making it worse. 23 and 11 helps me out with some of the numbers here. Okay, the number of protons is the same as the atomic number. If it has an atomic number of 11, then it has 11 protons. You also typically have the same number of electrons. And as far as we're concerned from my classes, we haven't done anything different so far. Those two are going to be equal to each other. So if it has 11 protons, then it's also got 11 electrons. To find the number of neutrons, up here it tells you that the mass number is the number of protons plus the number of neutrons. So if we want to find the number of neutrons, what we're going to do is we're going to do the mass number minus the atomic number. This is a little bit confusing. I'm using somebody else's worksheet in order to do this, but we're going to do mass number minus atomic number. When you're set up like this with the isotopic notation, you basically have your little problem set up right here. For chlorine, it would be 35 minus 17. So for sodium, we're going to do 23 minus 11. Well, that's 12. Okay? This next one shows us that we can work kind of backwards. The atomic number determines our element, so I'm looking for element number 17. And looking at my periodic table, I'll see that that is chlorine. I did the same one up here. So that'll have the symbol Cl. And we can write down chlorine. Okay, it has a mass number of 35. We determined that already from this previous problem. Now, we've already got the isotopic symbol, which is 3517 Cl. Number of protons is the same as the atomic number. That bottom number here, this number here. It has 17 protons and therefore 17 electrons. It has equal amounts of both. And then in order to do this, we just subtract. That'll be 18 neutrons. Okay, the last one here is potassium. its symbol is K. The periodic table is going to tell me that it has an atomic number of 19, and it has a mass of 39.1, which that's going to round to just 39. So we can use those numbers over here to write 3919K. It will have 19 protons and 19 electrons because that's represented by the atomic number. And when I subtract 39 minus 19, I'll end up with 20 neutrons. That's all we have to do in order to do just basic subatomic particles and to do isotopic notation. Now, I'm going to add one more thing, which is how to do isotopes. Let's see, yeah, that'll disappear. Alright, whenever we have an element that has a dash after it, like if we have Cl-37, this number right here represents the mass number. And when you see a dash like that, it means it's an isotope. An isotope is an atom of an element that has a different number of neutrons from normal. So watch this. If we do the isotopic symbol for chlorine 37, 37 would go at the top. Chlorine, according to the periodic table, still has an atomic number of 17. We just did chlorines on the other page that I was on. The periodic table says it has a mass of 35 and still an atomic number of 17. Because they both have an atomic number of 17, they are both chlorine, but they have different mass numbers because they have a different number of neutrons. If we break this down for a minute, this atom of chlorine has 17 protons. How I know is that's the atomic number. It has 17 electrons because those two should be equal to each other. The number of neutrons was found, remember, by subtracting 37 minus 17. That's 18. Alright, this, I'm just kidding. I'm thinking of my first one. That's 20. So if you're going, wait a minute, 37 minus 17 is 20. This one over here has 17 protons. Since that's equal, electrons are equal, it has 17 electrons. And this one has 18 neutrons. So you can clearly see that the one thing that's different between the two of these is the number of neutrons. This one has 18, this one has 20. Otherwise, it's still chlorine. So you do isotopes exactly the same way. Isotopic notation is done the same way. Finding the number of protons, electrons, and neutrons is done the same way, except you don't have to go look at the periodic table to find the mass because it's given to you right there. One more thing about this, you can also write it as, the full word. You can write that out, chlorine-37. Chlorine 37 is how you would read that. So whether it's the symbol or the full name, isotopes are done exactly the same.